Main reason I wanted to get you exposed to this particular problem is the perimeter stuff at the end. I think it's the first time we're seeing that on there, but the first part is just area, right? So just top curve minus the bottom curve. It gives you your X. You can plug the 1 in for the X and get the Y variable right there. Same thing here. You can plug the 1 in for the X, get the Y variable right there. So, but you're using the X as a take you across your body area because it's top curve minus the bottom curve. So go left to right. So you see all my work for letter A right there. It's just top minus bottom, integrate from 0 to 1. Got an easy UDU right there. You know you've got a single E in the problem. Let your U equal that power. Do a UDU right there. Easy integral here. Be careful. Plug it in your 1, plug it in your zeros. Get that exact area right there. Letter B, we're supposed to write an expression. We don't have to evaluate it. Just write the integral expression that gives the volume of the solid. Okay, so we're going to go about the line y equals -2. And so remember, so everything's in terms of x's right here. You're going to go from a curve to a different curve there. We're going to go use this disk method perpendicular to the axis of revolution. Your capital R is the distance from that axis of revolution to the farther edge. Now, when you measure from the x-axis up, that's y, but you travel 2 units just to get to that x-axis there. So that's going to be a 2 plus y. And then that farther edge is that x e to the x squared equation. Now your little r, sometimes people get confused since it's below the x-axis, but it's the same exact thinking. When anytime you measure from here up, it's going to be the same thinking, 2 plus y. And let me explain that to you, because when this is 2 units total, and then your y is a -2x, right? And so when you do that 2 plus y, you do the 2 minus that 2x right there, and it's going to start off with that 2 units, and it's going to subtract that out for us, okay? So we're just going to travel then the distance from here to that curve. So even if it looks a little bit different picture, if it goes below the x-axis, if you stick with your 4 big scenarios and variations of those, like you're going to be fine with your disk method on the AP test, right? So just pretend for a second if it was above the x-axis, what would it be? It would be 2 plus y. So do the same thing even if it's below. It's going to work out just fine. And then the fact that your y is the negative, it's going to know to subtract that out, right? Now, and then you just got your pi guy out in front. We got the capital R squared minus a little r squared. This is a no calculator problem. So that's why they're just having to set that up. We don't have to actually work that out. Now the perimeter on the last part of this, this here, so this distance, you're just doing the distance around that shape, right? So this distance here, you can use your Pythagorean theorem or you can use the distance formula, but this is just 2 units and then that's 1 unit. And so that's just going to be the square root of 5. All right, I just used the Pythagorean theorem to get that square root of 5 part. And in this part here, this y value is a -2. So that means this distance right here is 2. And this y value is e. So the distance from there up is e. So those 3 parts of it is real easy. It's just that plus that plus that. And then now the challenging part is you need to do this arc length right here. Now in your blue packet, I'm not sure why I didn't put it on the first couple pages, but on the 3rd page of your blue packet where it says the stuff you must know code, right here, arc length. Arc length formula, we did this in 7.4. That's the integral of the square root of 1 plus the derivative squared. So we need to know that formula. And so I did that down here. I did the integral of the square root of 1 plus the derivative squared. And so that y, that f of x was that x e to the x squared equation. So I did that derivative real quick, and I'm going to take that and plug that in place for the f prime squared. So you don't have to actually work it out or anything there, but that's your derivative that you're going to throw into that formula. So if you just know that formula, you can do the integral between 0 and 1 of that 1 plus that derivative squared right there. So that's just a good one. We've done integrals before, we've done areas and volumes before. Now we get to see a perimeter. You'll see another perimeter problem in the future. There's me working out the distance formula, but you don't need to do this for it. You just use the Pythagorean theorem right there. Kitchen table.